by now we've pretty much developed the solution that we're going to take for this robot application. Okay, and you can see on the left here we've got quite a long feature tree, okay, of commands, and when I break it down you'll actually see there's not a whole lot in it, but it does get lengthy there just for the small application. What I might do is I might go ahead and simulate the robot, okay, and I would just want to show you a couple of things within the simulation. So just there, even if I just stop it and play it again from the start, we see we've got a home position here and we're just moving across and we're waiting. Imagine this is a conveyor station over here that's feeding down parts to us, okay, and we remembered we could get two different types of colors. Color one was red, I think, yes, because two sensors would be on, and then the other one would be black because only one sensor would be on. So that's just waiting for the part sensor to say that a part is in position, okay, and then it will go ahead and pick up the part. So what we'll do is we'll just do, so there's the part sensor, and we'll say it's a red part first. So you'll see it go down, picks up the red part through the suction cup, brings it kind of back around this way to my left, and it starts palletizing it, okay, and I think there's 12 positions there that I tweaked it to fill up that pallet, and we can watch that in our variables. We see what color it thinks it is, so it thinks it's color 1, which represents red, and then it's going over and it's filling the red count, and we're just doing a palletizing technique there. And once we get 12 filled up, it will ask us, it will stop the flow of the program, and it will ask us to replace the red palette, okay. So that's all right, and I think that's straightforward enough, and we can see the simulation for that there. So I'll do 4 across and then 3 rows down. So the next thing that I just want to show you is the black, and really you can see this is all part of the red here, and if I double click even on this, you see how it brings that command down, or that kind of group of commands, because they're all embedded in. So you can see really that's actually kind of the real bones of the simulation or the program itself. It goes over, it picks it up, and then depending on what color it is, it will do either this bit of script or the below bit of script. So what I'm going to do is I'm going to turn off the color sensor, because then what's going to happen is it's going to go into this group of commands down below. So it's finished leaving off that last one. It goes down and it's going to pick up a black one. So you see it's going to move into these commands here, and it's going to swing around to my right. Now what I'm saying is it actually goes to an interim station before it palletizes it here. You can see it's a group of pallets. So it's after placing a part down here. And what we're expecting it to happen, if you can imagine there's another machine over here that's separately controlled, maybe by a PLC or something like that. And what it's going to do when the part's in there, it's just going to come down and it's going to drill a hole in it or something like that, okay? So there's a separate bit of I/O, separate bit of machinery over here that's doing that job for us. But how do we interface a wee bit of communication between that to let the robot know, okay, something's done and it's ready to be picked up again, so that we don't get the two machines colliding? Now we're just going to do a little bit of basic handshaking. That's what it's called here, between two machines, or two communications between machines. Now you could set up, like say, Ethernet communication or something that would be more sophisticated and maybe a bit more potential to do, I suppose, more things with it. But for the moment, we're just doing a simple I/O handshake, okay? So what I need to do is, I actually have an output, okay? So you can get two sensors, transmitter and receiver, okay? And basically, if you set one sensor on the robot, so you attach to the robot, and then the other sensor onto the machinery that would be linked into the PLC, or the other set of machinery, that's the controller that's looking after that. So you'll see I've got a digital output that I've set high. That's basically just said the robot is clear, okay? So you'll see, oh, why did it move around on me? Oh, we gotta just, as I changed some of that, we've got to just look back at it. So if we press, again, just go into simulation, let's look at our I/O, yeah, okay, simulate that. So I should have pressed pause, maybe don't stop, I think that's what I pressed. So it goes down, it picks up the black component. So it's coming around here to the black, goes down, pops the part off, so it does the suction cup, lets it go, and then it gets out of the way. And it turns on an output that says, if I just move this over here, you'll see it says the robot is clear. So that allows us to basically, that's an output that'll transmit a signal over to the receiver on the other I/O. Then that knows the robot's out of the way, so it can go ahead and do its pressing or whatever, and then when that's done, it sends an output back over to the robot, which will ultimately get an input, because if the other machine sends the output, it will come as an input then on this transmit receiver sensors. So if I say okay, the press is complete, you'll see the robot will now go pick up the part and then bring it into its palletizing location. So if I just leave that simulating now, so it'll go around, goes back to the home, comes in, picks up the part, thinks it's a black part because I haven't changed any of the inputs. It'll go down. Now I've left the output from this other station as high, so I'll just go down and pick it up, and then it'll come back down and pick it up again. So it's just dropping it and placing it, and there's a wee bit of I/O handshaking between the two controllers, between this robot controller and between, you know, this machine, the CNC machine or this press machine or whatever it is that we're pretending to simulate. That it's just doing that operation before it actually gets palletized at the end. So it's just how we can do a bit of a simulation with the kind of limited resources we have here. All it is just an I/O, so you have an input because the output of the other machine is going to send that across, so the robot will receive it as an input, and then again the robot, to let it know it's clear, it sends the output across, so the PLC will receive that as an input signal, and then they can kind of communicate between each other. And just looking at this, you know, when you're evaluating your performance, you'll see the robot, after it's finished with the black, always comes around here to pick up a part, which probably isn't the most efficient thing. Really, the home position should be just above where it picks up the parts, because that would be the kind of path, or sort of least distance path, I suppose, for both stations to get back to. Because you'll see after this palletizes, drops a part in, it has to swing all the way around to here. So this is just where I started it, but you know, on reflection, we should really have put maybe the starting point for both as there. So you can always look at fine-tune your performance, evaluating it, and see, talking about these discussions. Okay, so that's all really for this video. It's just showing you how we're simulating kind of interaction with another set of machinery, maybe PLC controlled, or it could be, you know, CNC machine or something else. And basically we're just doing that through some I/O handshaking for the simulation purposes. You know, you can use that in industry. You can get some transmit and receivers that will do that. Usually you might just network all your machines together so that you can do some Ethernet communication between them, because then that way you're not using up some I/O. You can just do some commands between it. So there's different ways around it, but just for the purpose of this simulation, you'll see that's what we'll do. And this is essentially our program here, and we've just got two separate kind of palletizing techniques for the different colors. So we're handling the two different colors, which is great. We're also interfacing with, you know, another simulated bit of machinery. Just in terms of the black, it does a drilling or a pressing operation before it gets palletizing. The red goes ahead and gets palletized straight away. And again, we can see what our count is at. For the black, I think I only just do up to about 12 or 8 actually pallets, so we may as well actually just play it through while we're nearly there, because then that'll just show us the pop-up, which we didn't get to see in the last video, when the pallet is complete. So basically when the pop-up happens, it sends a message, the robot will stop, it sends a message to the user and asks them to replace the pallet, so no more operations will happen at the moment. So you'll see this should hopefully come around. Again, it does this little interface there with a separate machine, make sure the part gets drilled or pressed or whatever you want to think it is. And then it brings it round, pops it off. That should equal 12 now. Or is it? Oh, we didn't get our pop off. That actually has replaced it to 0. We probably have this, we have to move this if command in a little bit closer in with the palletizing sequence, because it actually resets before, so I actually have to move the position with that. Okay, again, another failed attempt at that, but not to worry. So then that's the way we will go ahead, because we don't want this to skip through just yet. Okay, we want to get that pop up. And then just on that as well, on the suction cups, last point, you know, we're keeping, if you look at the IO, we're keeping the suction on the whole way as it's taken apart across. You know, that could be fair enough that you might want to do that. You could look at maybe more efficient ways of using a vacuum sensor as well, that once it detects that the part is fully sealed on, you don't need to keep the suction cup on the whole time. And we've seen that in some of the labs that we have with the actual robot itself. So it's just some other performance enhancing that we could look at. Again, you could look at going through the speeds and some of the accelerations with the robots of the joints as it's moving. But overall, I think, you know, we've used the Move L in the proper locations. We've used Move J where it's needed to, and yeah, that's our full system. So we're just going to look at kind of the final aspect of this, which is just adding in a little bit of safety IO and some safety commands to it, just to again give us as close to the full experience as possible as what we do with the robot.